Hello, I'm Amy Rose. We will learn about doping in a semiconductor. This is a bonus part of closed packing structures. Doping is the intentional introduction of impurities into an intrinsic semiconductor for the purpose of modulating its electrical, optical, and structural properties. The doped material is referred to as an extrinsic semiconductor. It uses two types, p-type and n-type semiconductor. P is for positive, and N is for negative. This is in accordance with octet rules. Atoms are stable when there are 8 electrons in their valence shell. If not, atoms readily accept or share neighboring atoms to achieve 8 electrons in their valence shell. In the silicon lattice, each silicon atom is surrounded by 4 silicon atoms. Each silicon atom shares one of its electron in the valence shell to its neighboring silicon atom to satisfy the octet rule. For example, in a p-type semiconductor, that can be doped with boron, means one atom less than in silicon. On the other hand, in an n-type semiconductor, that can be doped with phosphorus, means one atom greater than in semiconductor. These types of semiconductors, you could have seen in electronics. Electrical physicist Percy the Bandicoot can help you, and is used in PC as well. You can learn with computer teaching assistant Ben Tennyson. Let's meet him. Hi Ben, nice to meet you.
Oh hi. You look pretty, aren't you?
What would you like to see the type of semiconductor?
The one we're looking for, computer semiconductor.
Okay, you know Ben, silicon is first made of sand, right? Made up of 25% silicon, especially it's made up of quartz, in the form of silicon dioxide.
Like in the electronics factory, how do they manufacture semiconductor?
Ben, the first step is the load of silicon sand. Next step, the excess material is disposed of, and the silicon is purified in multiple steps to finally reach semiconductor manufacturing quality, which is called electronic grade silicon. This is probably forming as a monocrystal ingot. Each ingot will weigh 100 kilograms.
Is it really heavy?
Yeah. At least many workers can lift them. Then the ingots go to slicing phase where individual silicon disks, called wafers.
The one like from Intel processors?
Yeah, definitely. The wafers are then polished until they have flawless and mirror-smooth surfaces. Blue liquid is a photoresist finish used in photographic films. A single transistor would appear like if we could see it with the naked eye.
Isn't it bright too?
It looks bright, but not to be exposed too much on the eye, causing to lose eyesight. Then the washing and etching can be done. Then once the photoresist is removed, the desired shape becomes clear to see.
Well, Amy, how does the doping start?
Through a process called ion implantation. The exposed areas of the silicon wafer are bombarded with ions to alter the electrical conduction. Ions are propelled onto the surface of the wafer at very high velocities. Then the wafers goes through electroplating in a copper sulfate solution. Copper ions are deposited onto the transistor through a process called electroplating. The copper ions travel from the positive terminal, anode, to the negative terminal, cathode, which is represented by the wafer. Finally, the wafers are then sliced and divided into numerous semiconductors.
That's what automated machines do. So in that case, the computer semiconductor finishes manufacturing, and they put them in a CPU slot.
So, that's what the manufacturing process worked. Like, comment, and subscribe now.